Those of you that didn't read my badge on the way in, my name is Martin Davis, and I am the Public Programme Manager here at the Royal Institution. So, has anyone not been to the Royal Institution before? With a quick show of hands? Quite a few people. So for those of you that don't know what we do, I put on a programme of events, around 60 or 70 every year, on a broad range of sciences, from everything from biology like we've got tonight, to quantum physics, to psychology, to all kinds of different things, all aimed at anyone with an interest, and all free to our members. So especially if you're under 25, it's only 13 quid a year, so I definitely recommend signing up. Just a quick plug for our website. We've had a really successful launch of our Royal Institution channel, the RI channel. Our video about superconductivity on a magnet going around a Mobius strip has just gone over 1 million views. And as of today, we were at, like, I think it was 99,800 or something subscribers. So I reckon there's probably over 200 of you in the room. If any of you have a YouTube account, please subscribe to our YouTube channel, youtube.com/The Royal Institution, and then hopefully tomorrow morning I can walk in and tell everyone that we've now got 100,000 subscribers to our channel. So if you could do that for me, that would be really, really good. Thanks. But just a little bit about tonight's event. Just please, as usual, keep any mobile devices quiet and silent. Absolutely fine to be tweeting along, blogging along. You see you've got the hashtag and everything up here, so that's great. We love people to get to interact with the events. That's really good. But just make sure you don't disturb our speakers and your phone doesn't go off in the middle of the events. As you can see, there's fire exits everywhere, so no need to. And we've got no scheduled fire alarms, so no need to panic about any of that. Other than that, it's just my absolute pleasure to say I've been working very closely with Society of Biology, who you can see on the banner behind me, particularly Natasha and the whole team. So a real big thanks to them for putting this event together in celebration of Biology Week 2014. And it's my great pleasure to hand over to the CEO of the Society of Biology, Mark Downs, who will tell you a bit more about tonight's event. Thanks.
Well, thank you very much for the introduction. It's fantastic to see so many people here tonight for our debate this evening. This is the third time that we've run Biology Week. Many of you will know that the Society of Biology is a membership-based and membership-led organisation. We have about 15,500 members individually, and we have around 100 organisations across the entire spectrum of the biosciences who we represent on a lot of generic issues. And of course, one of those key areas where we work is around education and training and public engagement, where we have a voice that brings together all those different aspects of biology. And this is the third time we've run Biology Week, and it's all about, of course, communication and engaging people. We had a fantastic event last night at the Houses of Parliament. We've had an awards ceremony. We've had events going on around the country, in schools, in pubs, quizzes where people are participating. We've had a whole range of diverse activities, including hands-on practical biology, where you can go to a particular regional event and spend a whole day finding out about different aspects of the biosciences. And the events have grown year on year, and we're absolutely delighted that it's continuing to expand. So it's great to see you all here this evening. And of course, for the Society of Biology, communication of science is incredibly important. And what better place than to have a debate at the home of communication of science, starting here in, 1799, hugely long history. We've all probably engaged with and inspired by the Christmas lectures which have taken place here. 10 elements were discovered here. Faraday did his work on electromagnetism here. It's got a huge history. I think that's very fitting for the debate tonight and our focus on communication. So I think that's enough from me, and I'd just like to, before we start, add my thanks to the panel for coming along tonight and spending some time with us. We're looking forward to the discussion. And it's a great pleasure to hand over to Professor Chris Whitty. You've got the CVs, I think, in your pack, but Chris wears many hats, an expert in public health, but currently on secondment to the Department for International Development. So Chris, over to you as Chief Scientific Advisor, I should say. Over to you, Chris.
Thank you very much indeed. And I've always wanted to wear one of these because it's the closest I'll ever be to a helicopter pilot, which was my childhood dream. So additional fringe benefit. This is actually a very important debate, and it's a very live debate in the world at the moment. As I'm sure all of you know, malaria is one of the world's great killing diseases. at this point in time. Around 600,000 people a year die of malaria still, and many more actually catch it, and it interferes very majorly with their life, their development, their schooling and everything. It's a very, very major disease. So that we should deal with malaria is one of the things which the UK has felt for over a century, and the first UK Nobel Prize for Medicine was in fact in the biology of malaria. And I'm surrounded by 4 of the world's, and certainly the UK's, great biologists of malaria, taking slightly different disciplines, to debate whether malaria should be eradicated. Now, this is not as straightforward a question as I think it might at first appear. Because on the positive side, if you succeed in eradicating a disease, that is a gift for all time to all of posterity, everyone else. Eradicating smallpox, for example, was one of the great public health achievements of the last century. On the other side, failed eradication campaigns, including the first failed attempt to eradicate malaria, suck up resources, lead to very major breakdowns in control programs very often, and can lead to a collapse in morale and a rebound of the disease. So trying and succeeding, fantastic. Trying and failing, disastrous. And within the malaria community, there's therefore quite a strong split of opinion as to whether we should be trying for eradication. Nobody disagrees that it would be lovely if malaria had gone away. That's not in doubt. The question is whether trying to eradicate malaria is better than trying to control it. And the final thing I'm just going to do before I hand over to our speakers is just to define a few terms they'll be using, so in a sense we have a common language. The first of which is, you'll hear people talking about eradication. Eradication means getting rid of the disease everywhere for all time, like smallpox. Some people talk about elimination. Elimination means getting rid of the disease, but in a geographically defined place. So we eliminated malaria from Europe after the Second World War. It took a considerable effort, a great public health achievement. And then there's control. And control is what you do when you try and get the number of deaths and the number of people suffering the disease to the lowest possible level you can, but you don't try and go that extra mile that actually takes you right down to zero. Because that extra mile, that last mile, takes a huge amount more effort and a huge amount more money and resource than actually much of the control effort that's gone before it. It is a very major commitment if you decide to go for eradication. If you're going for eradication, you're going for, you win completely or you fail. Whereas control is something you just aim to do it the best you can, and you do it for as long as you can. So they are quite different concepts. It's rather like a huge capital investment compared to accepting a continuous recurrent expenditure, for those of you economists. So with those, I hope everyone agrees that that's a reasonable framework. So with that, we've decided to try and alternate the people with the strongest opinions. The four speakers in front of you, Robert Sinden from the University of Oxford, Ellen O'Reilly from the London School of Hygiene and Tropical Medicine, Janet Hemingway, Director of the Liverpool School of Tropical Medicine, and Tony Holder from the MRC Research Institutes. So those 4, I think, are going to give you a fantastic debate this evening. They've each got 5 minutes to make their pitch. I've asked them to be short, crisp, and controversial. And then there'll be a short, moderated discussion, after which we'll throw it open to you, and then at the end, they have a couple of minutes each if they want to say a few wrap-up comments. So, Robert, over to you.
Okay, let's go straight in at the deep end. Yes, I believe we should aim to eradicate malaria, full stop, right? But now, going into a little bit more detail, I think, for me, actually keeping the objective of eradication as the driver of our research effort produces a balance in the way we apply our knowledge and the funds to undertake the research. Now, if you look at the picture up on the wall behind me, right, if we were looking at control, we're treating a person who has malaria, the parasites that we would be wanting to hit are those 3 circles up at the sort of 2 o'clock position. On the slide. They're the stage of the parasite that lives in our blood at that point and causes the disease. And so you would focus on those in order to get those out of the body and stop the disease in the person and save their life. Absolutely. Of course we should do that. Right? But in the work that has been done, particularly over the last 30, 40 years, in focusing on that objective, what has happened is that we've forgotten that those parasites that are the target are not the ones that transmit the parasite from the human body into the mosquito and then back into other people. And the two dark dots up at the top center at sort of 12 o'clock in the picture, those are the parasites which cause the infection of the mosquito. And we know that their organization and their metabolism is different from that of the blood stages. Right? So in targeting these pathogenic stages, the stages that cause disease, we're missing those that cause the infection in the next people. Therefore, by definition, our treated person has still the potential to infect somebody else. And therefore, the expenditure on the research, as Chris said, is interminable. And we're talking of billions of dollars a year. Right? And I think that is a false policy. What we should do is keep eradication in our objective, to aim to stop the parasite either getting into the mosquito or getting back from the mosquito into the human body. That way, we reduce progressively the number of cases over time. Therefore, the amount of money we have to spend on treating people will go down over time. And hopefully, what we'll be able to do is to push malaria from the areas where it is currently weak, poorly embedded in the community, push it back to its heartlands and release more and more of the world into an area that is malaria-free. Because if we look, the campaign that Chris identified, we got rid of malaria from the southern areas of the United States, from the Mediterranean, from northern Australasia, right? And the benefits that have accrued in those populations are quite phenomenal by comparison to the areas that are still malaria affected. So yes, I think we should aim at eradication. We should certainly aim at preventing the parasite from getting across from the human body into the mosquito vector and back into the human body. And that requires a balanced portfolio of treating people, of course, but making sure that those people do not transmit into other cases.
Eleanor.
So I'm the pessimist tonight. I would love Bob to be right, but my fear is that the underlying biology of the parasite and also to a certain extent human behavior makes this an impossible task. If we think about the diseases that we have eradicated, I think I'm right in saying there are 3 pathogens that have been eradicated from the world. Smallpox, rinderpest, guinea worm. Have we done guinea worm? Not quite, okay. So we've done 2, smallpox and rinderpest. Rinderpest is a cattle virus. Both of those were eliminated or eradicated because we had incredibly effective vaccines and we had a single host, or not quite for rinderpest, we had a very effective vaccine. For smallpox, only humans get smallpox, nobody else gets it. There's nowhere it can hide, and we had a very effective vaccine, and nevertheless it took a very long time. So that was the easy one. So the first point to say is we do not have an effective vaccine for malaria. We've been working on it for over 50 years, and the best we have is a vaccine that reduces the number of clinical cases of malaria by about 50% for about a year after vaccination. But all of those people who are protected from clinical malaria can still be infected and therefore transmit. So we've done it for 50 years. We do not have a vaccine that could contribute to eradicating malaria. The reasons for that are very complicated, but the one I want to focus on is that the parasite is genetically extremely variable. If you think making a vaccine against flu or the common cold or HIV is difficult, malaria is orders of magnitude more difficult than that. That's because there are no such thing as strains of malaria. Just about every malaria infection in the world is genetically different from any other malaria infection in the world. Malaria parasites are as different from each other as we are from each other. And one of the reasons for that is actually a bit like humans. In order to transmit malaria from one person to another, it has to go into the mosquito, but it also has to go through sexual recombination. It is impossible for malaria to go directly from one person to another without reassortment of all the genetic material in the parasite. Now, the few parts of the world where malaria is genetically very simple, in the Amazonian rainforest, small population size of the parasite. But for most of the world, the parasite is genetically mixing all the time, and getting two different genetic variants of the parasite into the same mosquito is very common. So every time you get a new malaria infection, it is genetically different. And I don't think, I've said this to Bob once, I remember, there's any other pathogen in the world that has an absolutely obligatory sexual stage at every single transmission event. And for me, that means the genetic variation makes developing and sustaining new drugs and new vaccines really difficult, because once you put strong selection pressure on that, be it a drug or a very effective vaccine, you will immediately start to select for what we call escape mutants, parasites that are not susceptible to the drug or the parasite, and they will spread like wildfire. The harder you try to suppress them with that drug or the vaccine, the more selection you put on them, the faster they will spread. And I don't think we can keep up with that. The corollary of that is, if we get a new drug, an entirely new class of drug for which there's no existing resistance, or a very effective vaccine, then if we want to eradicate, we actually have to hoard those new tools. We can't allow them to be drip-fed out into the world bit by bit, because every time we use them, we'll start selecting for resistance. So you can use those new vaccines or new drugs to control or attempt to eliminate in small areas the parasite. But if you try to use them one by one for eradication, you will fail, because you will get resistance. So if you want to eradicate, we have to develop these new drugs, these new vaccines, new insecticides or whatever, and hoard them until we have an arsenal of maybe 4 or 5 entirely new tools, and release them all at the same time so that we clobber every single parasite. From a public health and political point of view, I don't think anybody would allow us to hoard a really effective drug or a really effective vaccine.
Thank you very much. Janet.
So from my title, Insect Molecular Biology, you might expect me to come up with a very technological answer to this. But I'm not going to. I've literally just got off the plane from India. And I've been in India working with an indoor residual spray program, which is one of the things you do to actually control the mosquito vector. And I guess my first statement is that if malaria was a disease where the heartland was in Europe or the Americas, we would not be having this debate today. With the tools that we have today, we would have eradicated this disease. Why can't we do that with the heartlands actually in the tropics? I think there are several reasons. It's a disease of poverty. If you were going to design houses that would act as ideal insectaries for mosquitoes, you would design an African hut or an Indian hut or a Sri Lankan hut. Mosquitoes thrive there. The parasite cycle, the malaria cycle, thrives there. So rather than improve people's housing, we spray insecticide on the insides of the houses. And if you spray the right insecticide at the right time in the right concentration, and the mosquitoes are susceptible to it, it works. But having come back from India, where they're spraying the wrong insecticide with the poor concentration, with the wrong formulation, and because of politics, they're 2 months late in spraying it, and they're wasting huge amounts of money trying to supervise spray teams who are using outdated technology. They're getting 12% of the houses sprayed. They're surprised they're not having an impact. If we're going to use the tools that we've got today in that format, we will never eradicate the disease. If you layer on top of that issues of resistance, then we've got a serious problem growing. So how could we take this forward? We've got some great examples of good elimination that has gone ahead, and some of those in the tropics. So I'll give you 2 examples. One from Sri Lanka, where I've spent the last 25 years working with the program there. In the 1960s, they came very close to eradicating malaria using an indoor residual spray program and chloroquine. They got down to 60 cases a year, and they stopped the program. And after 10 years, they had a massive epidemic, and the program went back up to over 200,000 deaths each and every year, and it stayed there for the next 15 or 16 years, and they found it very difficult to bring it back down. Sri Lanka is going for local elimination in the next year or so. What's the big shift there? Well, about 10 years ago, their president, Premadasa, who unfortunately was killed, assassinated, put in a social housing program. So 15 years ago, when I used to go to Sri Lanka, you had mud huts everywhere with thatched roofs, wonderful insectaries for mosquitoes. Now, if you go to Sri Lanka, you don't see that level of housing. The housing is still poor, but the housing is not good quality as far as the mosquito is concerned. And so that, along with a good control program, has done a huge amount to eliminate malaria. And this time they will eliminate it and they'll stop it. You may say, well, Sri Lanka's still on the fringes of transmission, although it's got ideal conditions for transmission through a large proportion of the year. But let's now move to Nigeria, where you've got year-round transmission to some of the highest transmission spots in the world. And there I've been working with a number of the oil companies. These oil companies have zero tolerance of malaria. They have over 3,000 employees sitting in Warri, in one of the highest transmission areas in Nigeria. Nobody gets malaria. Nobody dies of malaria. Why? You may say because they're all taking their drugs as prophylaxis. They should all be taking their drugs as prophylaxis, but actually we know they're not, because human beings, being human beings, they decide once they've been there for a year or so that they're probably immune. Not true, but even an oil worker and their families won't continue to take prophylaxis. But they've got good quality housing, they've got spraying going on, which is good quality, which is controlled, and they've got a decent proportion of the population taking prophylaxis and any sign of malaria, and it's treated. And it's very easy to get malaria coming in. So, for example, we were called in 4 or 5 years ago because they had 2 cases in several thousand of their workers. They had just 2 cases, and they wanted to know where the transmission was coming from. The mosquitoes were actually breeding on the golf green that they'd got there. We found them in the holes in the 18-hole set. So if you can stop it in malaria in Nigeria, putting the right amount of time, money, and effort in, it is possible, but it's going to be one heck of a task.
Thank you very much indeed. Tony.
So there's no doubt that the elimination program has had considerable success in terms of getting rid of malaria in many countries in the world. And to continue, there's no doubt that we will need political will, we'll need the money, and we will need new tools. Now, the new tools that we will need to do this are tools that we don't have, and they're going to be based on knowledge that we don't have. And so we're going to be in a position in the future that unless we get serious about trying to advance the basic understanding of the parasite and the disease, that we won't be able to develop the tools that we need to continue the elimination process, but also to facilitate control measures. So what am I thinking about? So if we just return to the question of vaccines and how effective they've been, for example, for smallpox and of course for polio and rinderpest. Well, as Eleanor said, the parasite is a very complicated organism. By trying to develop vaccines, we're playing the parasite's game because it has had to co-evolve with the host's immune system for many, many years. And the real challenge is, can we actually develop a vaccine which will get around the fact that the parasite can evolve and develop ways of escaping that vaccine? Well, so far, our record hasn't been very good. And so far, we've been very, very slow in terms of trying to develop vaccines. So just as an example, the vaccine that was mentioned that is undergoing late-stage clinical trials, that was based on a discovery made in 1984, 30 years ago. The first clinical trials of that particular antigen, as it's called, were carried out in 1987. Just gives you an idea of the timescale involved in this. And, we're too slow and it's too expensive. Either we need to really improve our understanding and improve our speed of testing these things, or we are guaranteed to fail. Now, the other thing, in terms of treating the human rather than trying to prevent mosquitoes biting and feeding on humans and transmitting the parasite that way, the other major tool that we have are a number of drugs. And drugs have proved very effective over the years until drug resistance is selected for. And we all know that chloroquine, for example, was very effective when it was first introduced and for many years. And at the moment, we have so-called artemisinin combination therapies, which have, again, recently transformed the control of malaria. But already in Southeast Asia, we're seeing, even to these combination therapies, which are designed to make it harder for the parasite to evolve resistance, we're already seeing clinical resistance to the frontline drugs. And again, this is because the parasite can evolve under strong selection pressure and develop ways of, in this case, avoiding a new drug. So what is the answer? Well, for me, the answer is we need, if we're serious about really tackling not just the treatment and preventing morbidity and mortality, but clearing individuals of parasites, because it's the latent parasites that are hidden and in, for example, semi-immune individuals that are what are being transmitted by the mosquitoes. If we want to clear those, we need to develop new drugs that are effective at doing that. And we need to have not just one, so we always try to catch up with the evolving parasite. We need to be able to develop a selection, 4, 5, 6, or whatever the number is, ready to introduce them ahead of the parasite evolving. And we need to do it in combinations to really reduce the chance that the parasite has to evolve and to develop resistance to the drugs that we develop. So how do we do that? Well, first of all, if you develop a drug in the Western world, major pharma spends between $4 and $12 billion for every drug that's brought to market. That is a sum of money that is just not feasible to do in a disease such as malaria, because there isn't the profit margin for the pharma to do that. So we need to leverage current resources. We have to get access to drug companies' so-called crown jewels, the libraries of chemicals that we could maybe think of using as a starting point for new drugs. But we also have to understand the biology. We have to know what are the vulnerabilities. We have to know what are the new targets for drugs that we've never thought of before. We need to understand what's the vulnerability and target several of those at once so that the parasite cannot evolve to get around that problem. So what we need more basic understanding. We need more basic research of the parasite and its biology. And the good news is that's cheap. Compared to the cost of developing a drug, doing good basic science is cheap. So what we need to do is to develop new targets, new modes of actions, and understand and validate those, and then use that as the basis for developing drugs, leveraging those chemicals that are available, but basically do it faster and more cheaply than it's ever been done in the past. So good research is cheap and is doable. We need to get consortia of people that know what they're doing to do it properly, because none of this can be done by one individual or one group alone. We need to have experts in a whole range of different areas. And whether it's at the level of developing drugs or of applying them in the field, we need to do good research to provide high-quality insight and knowledge that will mean we'll get better at what we do, both in getting new tools and applying them most effectively. And that, to me, is the way forward.
Thank you all very much. So what I'm going to do, and I haven't warned the panelists this, I'm going to give each of them a chance to challenge one or two of the others on what they've previously said. And if they all shy, I will challenge them for them, because they've stirred up some ideas in me. Once we've just done a quick round on that front, then we'll throw it open to the floor. Because I'm hoping that this will have stimulated several people to want to ask questions or make comments. Robert.
Thanks. Okay, I think for me, one of the things that I would respond to the doom and gloom, it's too big a problem, etc. Concept. Yes, it's a big problem, but I think one of the things, picking up Tony's point, about the basic knowledge that we have to have in order to develop effective interventions, right? That basic knowledge has shown very clearly that in many ways, if we're looking for elimination, eradication, i.e. the reduction in the number of people infected, actually what we've been doing in the past in terms of hitting the human population has actually been the wrong thing. Because if you look...
Robert, are you challenging or are you making
another
statement?
I'm about to challenge, right? Because I think the key thing that we've got is to realize that we have perhaps been looking at the wrong thing. We should be looking, right, at what is happening in the mosquito vector. A person has 100,000 million parasites in the human body when the person dies, or when they're very sick. A mosquito that bites that person will probably have 5 parasites in that mosquito. Why are we tackling these 10 to the power 11 parasites when we could be hitting 5, right? This gets over, or sorry, it doesn't get over, reduces the problem of the speed of drug resistance. We've been looking at the wrong place in order to get an effective hit. So I agree with Tony. Yeah, use good science, but let's use it in the right way and attack the right stage.
Anna.
So I could respond to what Walter said, but I won't. So I'd like to support what Tony said, because it's not just that we need, for example, new drugs. We need to have choices in the drugs that we have. So we don't just need 1 or 2 new drugs that look a bit like the ones we've already got with resistance problems. We need, if we could have 10 or 20 or 30 drugs being developed, all on completely novel targets where there's no resistance, we could afford to use 5 or 6 of them and hoard 5 or 6 of them, and that might make a difference. So I think we do need to increase the number of options that we have from always just having 1 new drug or 2 new drugs in the pipeline. So I'd like to support that. I guess if I'm going to challenge anybody, it would be Janet, and say, it's quite easy, relatively, to control or eliminate malaria in areas where it's kind of hanging on, it's kind of endemic, but it's not rampant. And we've done that. And yes, you can control malaria, even in Nigeria, in a small population compound, small village, where you go in and throw everything you've got at it and don't worry about the consequences for everybody around in terms of generating resistance. You can do it. And it costs a huge amount of money, but you can do it. But that's different from saying we're going to do that in every household, in every compound, in every village, in every region of every country in sub-Saharan Africa where malaria is a problem. And not only is it a scale issue, but the more you use the tools, the more resistance you get. And also, the places where we have eliminated malaria are places where the mosquito vector is actually not that great at transmitting malaria. The places where we've made no impact at all are where we have an incredibly efficient mosquito vector, and it may only have 5 parasites in them, but there's an awful lot of them out there.
Janet.
So I'm not quite sure which one it's directed at, but we've all talked a lot about resistance. And the issues of both drug and insecticide resistance, and then how we're going to avoid resistance to the vaccines when they come. I guess my challenge really is it ever going to be possible to avoid resistance to the vaccines? Or is a vaccine so difficult to develop that it's really a one-off shot, and we need to be ready with the drugs and insecticide combinations to go with that vaccine, because we get one shot at this. And if we fail at that one shot, and we get resistance to the vaccines, then we're done.
Tony.
This isn't a challenge for anybody in the sense that I don't disagree with what has been said, but I think, first of all, that if we're serious, we're not going to be able to do this with one tool alone. It's going to have to be a combination of everything from improved housing through to a vaccine that works through to a new set of drugs that are effective. But just going back to Bob's point, I feel I need to defend a little bit what I said, in the sense that I don't think that we have to just make drugs that are targeted just to the treatment of disease, as opposed to drugs that will kill the parasites responsible for the disease, as well as the parasites that are transmitted to the mosquito. I think if we have an understanding of, for example, the metabolism and biology of both stages of the parasite, we may well find that there are targets that we could address that are present in both, and therefore develop a drug that could be effective against both stages. So I'm in that sense an optimist.
Great. So I'm going to do a challenge to each of you, and then we'll open it up. Bob, you talked about a balanced portfolio. Half the world we're eliminating, half the world we're controlling. Almost all the deaths occur in about 10 countries in Africa. So are you seriously saying we should take half the money away from those 10 countries? And the whole point about elimination is you can only eliminate where the malaria is not a big problem. In fact, almost no one dies from it. So we should take money away from countries where malaria is dying, we should put it into countries where malaria people are not dying, because there isn't much malaria and they're generally wealthy, so those people don't die anyway. Does that sound like a balanced portfolio?
The answer is yes, of course it can be, if you think rationally about it, right? In as much as I've not said that the clinical prerogative should be forgotten. Of course we should treat people who are ill, right? That doesn't decline, right? But in addition to that, I think we should be stopping people from getting infected and using, I think it was Eleanor's concept, right, that you've got the heartlands. There, of course, you're going to carry on treating people, stopping them from dying. But if you're going for elimination or eradication, what you're going to do is you're going to start out here, trying to eliminate and eradicate in those areas where transmission is relatively low, and push the parasite back using combined, right, treatment and eradication policies. Push it back. You're still treating the people here.
But
right?
where does the money come from this pushing back?
From governments, from public will.
So I'm surrounded by economists in government, and they talk about opportunity costs. You have to choose between one thing and another. If you try and do both, you do half as much of each of them. And that's my challenge to you.
If you do not eliminate the parasite from areas, you will not make cost savings.
Thank you. Right, I'm sticking to the, I'm going to do a second economic-ish question, and then I'll tend to do science ones. Janet, you're a very important scientist. You seem to be arguing that the way to get rid of malaria is to make people rich. Why don't you become a banker?
How do you know she isn't?
I used to play the stock market in my spare time as a youngster.
But your serious point was that actually the way to defeat malaria is to make people rich. And actually that would defeat a whole heap of other problems. Surely that is what we should be putting our resources into rather than just worrying about one disease.
I do think that it is a disease of poverty, but we're not going to cure poverty overnight in the vast swathes of Africa, Asia and elsewhere. And so I think there's a balance there in terms of some of the housing. And I think the Sri Lankan example is a great example because they didn't cure poverty there, they just improved the housing. And those houses are still very small, they're still one room. We wouldn't like to live in them, but they do not actually support mosquitoes in those houses. And so just a small marginal shift there produced a huge shift in the biology of that disease, which means that it is not going to come back. Now, that isn't a massive shift, but it allowed people to actually climb out of poverty themselves once you'd started that progression.
Thank you. Eleanor, you gave a pretty gloomy assessment, I thought, that genetic variability, if I understood it correctly, means that a vaccine seems to be pretty impossible.
We could make a vaccine, and we might make one that works for a while, in the same way we've made drugs that are very effective for a while. So it's not that we can't make a vaccine, although we haven't managed to do it yet. But in theory, we can make a vaccine against malaria. My worry is that because of the genetic plasticity of the parasite, then exactly the same thing will happen as happens with drugs, that they work for a while, and then a beneficial mutation occurs and is selected for, and then that. So yes, I do think, and I do tend to agree with what Bob and Janet said, that actually focusing on the vector is probably, if we want to eradicate or eliminate, it's probably going to be easier and possibly more sustainable. The point I would make, though, about, which hasn't come up yet, about using vector control or using drugs or bed nets or whatever, is that you have to keep doing it day in, day out. to keep the pressure on. The advantage of a vaccine, if we can get one that works well, is that you can vaccinate somebody and they are protected for years, in the case of some of our very good vaccines, for life. And so it becomes something that you only have to do once or twice in someone's life, rather than, as with a bed net, every single night of your life.
So if we've wasted 50 years of large amounts of money into vaccine research, and even if we succeeded, it would only last for a few years, shall we just abandon vaccines for malaria?
I can totally understand that argument, and I am very pessimistic about getting a good vaccine. The payoff, if we can get one, is huge, because we could vaccinate children at birth and never have to worry about it again. My worry is that even if we do that, it might not be sustainable. And we have targets for vaccines that are not very genetically variable at the moment, but I worry that as soon as we put them under immune selection pressure, we will select for mutations. But it might give us a window. If we could have a vaccine that protected children for 10 years, and we could roll that out, it might give us a window to do something else.
Tony, your argument appeared to be it was jolly expensive to do use of things like drugs and nets, so let's just do some basic science. Is that a fair?
No, all I'm saying is that unless we do the basic science, then we won't have the tools that we will need in the future to develop those drugs and/or vaccines. So it's a prerequisite. It's not something to do instead of. It's something we need to do alongside, because obviously, with all of that knowledge that we generate from the basic science, we don't want to just leave it sitting in some dusty old cupboard and forget about why we're doing it. And we're doing it to provide the foundation for that development of, for example, of drugs. And the point of doing it is that we need to know what is the best way forward. A lot of, for example, drug development is trying to target the same old processes time after time again. We need to be innovative. We need to have evidence upon which to base our decisions. And as I say, this is also cheap. And from the point of view of the cost of drug development, yes, it's very expensive if we do it in the United States or in Europe. But why restrict ourselves to those two locations in the world? There are many very good pharmaceutical medicinal chemists in India, in China. There's the potential in places like Nigeria that we've talked about, where there is an indigenous pharmaceutical industry which manufactures antimalarials, but there is the potential there, because there's also a very good clinical base, there's a potential there to bring in research and do the research and development and manufacture in an area where the drugs are required. We need to be innovative to make things cheaper and faster. And rather than saying, we've got this much money, do we pay for this or do we pay for that? We want to leverage more so that we're not just sitting with one piece of cake we have to cut up. We want to make the cake bigger, and this might be a way to do it.
Yeah, lots of people want to make the cake bigger. Right, the floor is open. Seeing several hands, I'm going to start off with this gentleman here. Now, can you, if you've got it for a particular person, say, and can you introduce yourselves when you speak? So if you're a Nobel Prize winner in malaria, we know, and if not, we don't.
I'm not a Nobel Prize winner in malaria, but a kidney doctor. The reason I'm asking is this concept of controlling the vector is very interesting. Now, you suggested that, and I wonder, what do you mean? Can these mosquitoes, which obviously in tropical, they will be there forever, be changed in such a fashion that they don't accept the malaria anymore? Or can we have good mosquitoes swapped for these bad ones so that they continue to do the good things which mosquitoes do, but not the bad things?
Great. Good mosquitoes. Great concept. I'm going to take a few, and then that one, Janet, is heading your way pretty quickly. This lady here.
Hi. Great discussion. I'm an infectious diseases specialist, so, but not in particular malaria. My question to you is, how do you feel that climate change will affect the eradication effort with expansion of geographical area of more efficient vectors, such as the way that we're seeing with the spread of dengue now?
Great, thank you. Gentleman there with the checked shirt.
Even if tomorrow I was able to give you a big bag of all of the things you want, your vaccines and your drugs, do you think that we're in a position to be able to roll them out efficiently? Because even in cases where we've got the polio vaccine that was implementable with a couple of drops, that hasn't been effective. And one piece of research published in the BMJ has resulted in people believing that vaccines are associated with autism. And do we think that we're in a position whereby we would be able to use these effectively to see off malaria? I ask particularly because I've had a couple of friends who are clinicians go and spend some time in hospitals in Africa, and of the hundreds of people coming in to see them in the day, they had 2 bottles of quinine to hand out to whoever they thought it would be most effective for.
Fantastic. I'll do one more, and I'm going to go, the lady behind there, just dotting around a bit.
Hi, this is for Janet. I was just wondering, you talk about using insecticides and pesticides, but aren't there lots of other negative consequences? So it can build up in food chains. So I was just wondering what you thought about that.
Great, thank you very much. So 4 extremely good questions. Janet, I'm going to give you 2 of them. Who's going to be brave and go for climate change?
Oh, thanks.
I can have a little shot at that as well.
And relative efforts.
Yeah, okay, so the first one, good mosquitoes, bad mosquitoes. We've already got hundreds of good mosquito species, so there's only a very small proportion of mosquitoes species that actually transmit malaria. There is work going on to try and genetically manipulate those mosquitoes who do transmit malaria so that they won't. It will not be easy to do that for all mosquitoes, and it will not be easy to get the political and social will to actually roll those out, but there is work going in that direction. So that's a very short answer to something I could spend all day talking about. And I'm sure the other one you're going to throw at me is the one that came directly there in terms of consequences of putting pesticides out there. The amount of pesticide that we're putting out there with indoor residual spraying and on bed nets is very limited. They actually go out there on bed nets, actually impregnated onto the fabric itself, so there's no way of that insecticide leaching out into the environment. With the formulations that they're using in the indoor residual sprays, we actually put in there elements that mean that the insecticides in there are not UV stable. And so if people actually take those insecticides out and use them where they shouldn't, with the exception of something like DDT, which very rarely gets used these days, then that insecticide will fall apart very quickly. So what gets into the residual food chain from use of pesticides for malaria control? A tiny, tiny amount. So in relation to the good that it does in terms of reducing malaria transmission and, in fact, any other viral-borne mosquito disease or things like filariasis, where you've got all those vectors in the same place at the same time, it's a very unbalanced equation to be worrying too much, I think, about that tiny amount that might get into the food chain.
Great.
DDT, I think, is maybe a different issue.
Yeah, and just if I can do a supplementary to your first answer, getting a mosquito that can't get malaria is the easy bit.
Yeah.
Then how do you drive the gene through the population unless there's a selection advantage? That really, I think, is the fundamental flaw with that things. Great science, but it's not obvious how it actually works as public health. Robert, I think you were kindly going to do climate change.
Okay, I'll do climate change. Sorry, I'm just going to challenge you on a point. You were talking about the gene drive being a flaw. I think there are some very exciting experiments being done at the moment, actually, where gene drive mechanisms have been found, and they really do work. So I'm not sure it's a flaw.
Okay, it's not the first time I've heard that.
Right.
The first time was a while ago.
Climate change. Okay, by climate change, I presume you're meaning climate warming as a phenomenon. I look at this in 2 ways. One, there are areas of the world where, at the moment, malaria transmission is really very delicately poised, right? Potentially, the rise in the temperature actually could render those areas less capable of transmitting, and you could free some areas, right, from malaria. They might not necessarily be the most desirable residences in the world, right? Looking at the other side, yes, there will be parts of the world which currently cannot transmit. And okay, let's take the UK as an example, okay? That the climate may change enough that malaria not arrives in the UK, for those of you who don't know, it would return to the UK. There was malaria in the marshlands of the UK in the 1940s, right? And malaria has only gone from the UK since the 1940s, right? By the degratification campaign that has taken place, civilization, right? So I think, yes, there will be areas that will be at risk, areas will be released. Now, whether that's going to be a net positive or a net negative, I don't know, right? But, yeah, of course we've got to be aware of it, and we've got to be prepared to tackle it. But I think it may be in the more developed areas which will become at risk, where I think civilization may work to our advantage.
Hello.
So your question, I think, was a really interesting demonstration of how controlling diseases is actually an awful lot easier than eradicating them. Yes, delivering healthcare in many parts of the world is very difficult and very difficult to sustain on a day-by-day basis. But against that background, immunization programs have been hugely successful. The extended program of immunization that was rolled out by WHO in the 1970s, I guess it was, wasn't it, when it really took off, has led to millions and millions and millions of children being vaccinated. And for those of us that have worked in countries where infectious disease is still a huge problem, the one thing that you notice is that the easiest group of people to target with a health prevention mechanism are mothers with young children. And they come to the clinic and they will wade through floodwaters and all sorts of things to get their children to vaccination clinics. And it's been hugely effective, and it has reduced the burden of many, many infections by, incredibly well and very quickly. And actually new vaccines are being added to the EPI program all the time, and we're now controlling things like pneumococcal disease and meningococcal disease for the first time. And they are reducing child mortality by leaps and bounds year on year. That's control, and that is actually where vaccination really, really has strengths. You vaccinate once, you never have to worry about it again. But if you take polio as the example, polio is an extremely well-controlled infection. There are very, very, very few people being paralyzed by polio anymore. We have controlled polio with a good vaccine. But going to eradicate polio is now extremely difficult. It's what Chris referred to before as the last mile. It gets more and more and more expensive and more challenging the closer you get to the end. And the amount of money that you put in for those last few cases is orders of magnitude more than you would spend on just vaccinating a child. So that's the difference between control and eradication, and polio is a really good example of that.
And if I could just add to that, I agree completely with that answer, but it's a very good question about eradication. A long way away from eradication, in a place where there's a huge amount of disease, if you say to someone, will you tolerate a bit of interference with your life to eradicate malaria? Ask a mother in Nigeria, she'll hug your knees, because this is a huge problem. But when you actually get close to eradication, they almost never see the disease. That's the reason you can eradicate it. And then people are saying, well, why are you interfering with me? I never see this. This is what we're finding with polio. So these social issues actually become much more difficult the closer to eradication attempt you get. It's true for all diseases, it's not specific to malaria, and it is actually one of the big challenges. Right, 4 more questions. I'm going to go to the back now. The lady in the black thing up there, I'm trying to make him fit. Just so he's not too fit, then maybe there's a lady too along in a fawn top, as far as I can see in this light. That may be wrong.
I'm a first-year PhD student studying basic malaria biology. This is to Janet mainly. The example you make of Sri Lanka, obviously attempts there are admirable, but how much can we really use Sri Lanka being an island, having a largely temperate climate, having seasonal transmission? How much is that an example to transmission in mainland Africa and our vector control attempts there?
Pass it on.
And this is another one to Janet. I'm also a first-year PhD student.
I haven't seeded the audience.
You mentioned that if malaria was a problem in Europe and the Americas, it would be eradicated. How much, I mean, we've seen with the recent Ebola crisis that there hasn't been much political will until there was a perceived threat to the West. How much do you think that affects attempts to control or eradicate?
Right. Anyone who wants to ask a question just to Janet has to put their hand down till the next round. But gentleman up there in the white or yellow shirt, something like that.
Yellow, I think.
Well, first of all, could I just say that basically, being biology, I'm a retired teacher, and I cannot think of a better way of teaching biology and enthusing pupils with the love of biology than learning about the life cycle of the malarial parasite. It is intellectually my favourite disease. So, therefore, for that reason, I would be in favour of, control or eradication rather than elimination, so that the study of this amazing life cycle will continue, and not just because it's interesting in its own right, but because it will stimulate good, great biologists with God knows what spin-off in other areas of biology and cure of other diseases.
Right, that was a comment, so we're allowed another question. Lady down here in the jacket.
Hello, I'm a doctor, but...
no shame, that makes two of us. Yes.
Not in this field. And my question is mischievous, along the lines of one doesn't expect turkeys to vote for Christmas. But I wonder, given all of these difficulties with malaria, great fun though it is, aren't there other diseases that we should be putting public money towards that are lower-hanging fruit, like measles or some of the other horrible diseases? This is, I know, provocative to you guys, but I would really like to know what you think in the big picture.
Right, I'm going to ask one of these turkeys to vote for Christmas, and this gentleman down here, and then we'll stop.
Thank you. James Salmon, I'm a biology teacher. What about animal reservoirs of malaria? Does that mean that we really cannot long-term control it and eradicate it?
Grand. Okay, so the last one I'm going to give to Eleanor, and then we're going to give Janet a couple, because they were directed specifically at her, and then I think Bob wants to comment, and Tony, you can comment on any of them.
Okay.
Yes.
So the animal reservoirs. So for the human malarias, we used to say there were 4 malaria species that naturally occurred in humans. We now have to qualify that and say 5. And the new one is a parasite called Plasmodium knowlesi, which is actually a monkey parasite. And until about 10 years ago, there were occasional infections of people with Plasmodium knowlesi, and they all occurred in the lab where people inadvertently stuck their finger with a parasite while they were working on the monkeys. But we became aware, it was about 10 years ago, I think, of naturally occurring Plasmodium knowlesi infections in people in Malaysia and the Philippines. And it turns out that these are infections that people catch when they go into the forests for logging or for collecting, hunting and gathering, or clearing areas of forest for agriculture. And very interestingly, the people at risk tend to be adult males. The villages are on the edge of the forest, and they tend to be far enough away that the mosquitoes don't fly out and bite people. And Plasmodium knowlesi has turned out to be a very, very nasty infection. It causes really very unpleasant disease with quite a high case fatality rate, and it's an emerging infection in parts of Malaysia and the Philippines. The good news is that as far as we know, humans seem to be a dead-end host. So somebody with Plasmodium knowlesi comes back to their village, they tend not to infect anybody else. But it may turn out that actually there are via mosquito to human infections, but at the moment it seems as though most of the infections are coming directly from the primates. Apart from that, there aren't any animal reservoirs of human malarias.
Robert. You were going to talk about cuddly malaria.
The biology and the risk of eliminating malaria, right? I agree with you. I think as a cell biologist myself, right, Plasmodium is quite the most exquisite advocate of biology. It does it better than any other living system I've ever worked on. It is a stunning organism. But in terms of your comment, the reason I wanted to take your comment was that you were saying there was a danger that we might not have this organism anymore. The anecdote I want to give you is I came to work on malaria from a free living system, right, in the 1970s to work with Professor Garnham, who was the god of malaria, who discovered the fact that it went through the liver stage. And he, at a meeting not unlike this, held at the Royal Society, right, actually got up in the late 1960s and actually said he thought there was a danger that we might eliminate malaria from the world. So your thought has gone before you, right? But taking the point, right, that Eleanor was talking on, there are many species of malaria parasite, okay? There are 5 or 6 that infect man. There are hundreds of species of malaria that infect a wide variety of organisms, right? Most vertebrates, you will find, have got a malaria parasite somewhere. So we will still have something beautiful to study.
And I'm going to ask every member of the panel to say what disease they would prioritize over malaria if malaria had to be taken off the table to answer your one. I'm going to give you some thinking time. Janet, 2 were directed at you, and then I'm going to start with you, Tony.
So I'm going to combine the 2 questions I got, because one was about, is it easier in Sri Lanka to do this, but you couldn't do this in Africa? And the second one was about political will in Europe. And I'm not going to answer either of them completely directly. I'll start off by saying that, yes, in theory, it's an order of magnitude more difficult to do it in Africa than it would be in Sri Lanka. But we've used the same technologies in the LSDI program, which was on the border of South Africa, going into Mozambique, Swaziland, and there you've got very high-level transmission, not seasonal, not an island. We got all of the industrial people involved. We got the local governments involved. We actually managed to get the same sort of results there as we did in Sri Lanka. You can't eliminate there and keep it because you've got the malaria coming back in. But Sri Lanka, you've got the same. There's an awful lot of traffic between India and Sri Lanka as an island. You've got a tiny strait, and now the civil war's over in Sri Lanka, lots of people moving across there. But the political will, I don't think the problem is the political will in Europe or the States. The political will is more of a problem in the endemic countries themselves. And that may be a little bit controversial to say that, but having just come back from India, the national government is sitting in Delhi. Malaria is not an issue in Delhi. Malaria is a problem of the rural poor, again, in India. And so getting the political will of the countries involved to actually do something about this, make sure that they get the right drugs, the right insecticides to the right places at the right time, that you don't get stockouts, that you don't get counterfeit things coming into the market, that you actually make sure that you've got the right level of capacity on the ground, and that people are getting paid to do their spraying, rather than waiting for several months for their payment, is something that you need to deal with in country. It's nothing to do with Europe, and it's nothing to do with the States. And unless we can get that level of enthusiasm and political will going in the countries themselves, we have a real battle to actually take things forward. But we need to understand that a lot of the political issues are there rather than in Europe and the States.
Great, thank you very much. Tony, I'm going to start with you on the alternative to malaria.
Okay, so I mean, I think
it's been eliminated now.
To interpret what you're saying, you're essentially saying not a disease of the Western world, because there's a lot of research going into that. So what are the still pressing issues? And I would say they're helminths. They are the intestinal worms, schistosomiasis. These are really neglected parasitic diseases, but much bigger parasites than the malaria parasite. These are the things that there's still very little research done on. There's very little effort to control them. They don't cause fatalities, largely speaking, but they cause considerable morbidity throughout the world. So I would target them.
Janet?
Can I have 2?
If they're short.
Dengue and schistosomiasis.
Schisto,
similarly for there. Yeah. But dengue, because it is moving incredibly quickly, it is hitting some of the big population centres.
Just explain what dengue is, just in case.
Sorry. It's a mosquito-borne hemorrhagic fever. Transmitted by 2 mosquitoes. They're Aedes mosquitoes, not the malaria-transmitting mosquitoes. And there are serotypes that sweep through populations. So a serotype comes through once, You
That's
generally
enough,
have
that's enough.
dengue.
Yeah, no,
That's
no,
enough.
that's
Yeah.
enough, yeah.
So that's where I would go.
Great. Eleanor?
I would throw the money at those diseases for which we have effective vaccines, but which are currently too expensive to be rolled out everywhere that they're needed. And those include vaccines for hepatitis B, vaccines for pneumococcal disease and meningococcal disease, and one or two others. We have drug companies have been very successful in recent years in getting a lot of vaccines through clinical trials showing very high efficacy, but the manufacturing costs of some of those vaccines are still too high to make it easy to roll them out everywhere they need to be. So I would focus my money on the ones where we already know what the solution is and we just need to do it.
Robert?
Okay, there are two or three thoughts come up in my mind. I really like, Eleanor, your thought of aiming to, and I'll use the word again, eradicate, right? Using any money that is not spent on malaria to eradicate other diseases. I'd take those where that's within our grasp and do it, because we know that then we've dealt with that particular problem. I like that, right? Irrespective of what the disease might be, right? Picking up a point that Janet made, that I find, I'm going to pass it back to you to answer, all right? But it is this. The question is, are we talking about global money or are we talking about UK money, right? Now, you don't need to answer, right? In terms of global money, then you just look at the global impact of disease and expect the globe to pay. Now, which members of the globe pay, I don't know. The bit that I genuinely, picking up your point, Janet, that if it is correct, and that's why I'm looking to you, Chris, right, is if I understand it correctly, the cost of controlling, the projected cost of controlling malaria in Africa, right, is lower than the money that would be saved in terms of the gain in GDP, right? Such that, you know, the cost in Africa is $12 billion per year of lost GDP, and it will cost less than that, right, in order to achieve control. So why isn't Africa doing it? Because they're going to end up in profit, right? So it is a question, I think, just simply who pays, right?
I may pick that up at the end. I'd like to take at least one. I'd like to take one more round, and I'm slightly eating into the time of the final statements. But I think they're really good questions, and I think actually this will be really good. Mm. Yes, I was going to go up. Lady at the top there.
But there's people up in the gallery.
Ah, sorry, people up in the gallery. I do apologise.
Yeah, waving right up.
Waving, right. Okay, we've got one here, right at the far end, and then we'll go up to the gallery. Cheap seats. Yes.
Hi, thanks for a really nice discussion. I'm a malaria clinician and have spent most of the last 10 years working in Uganda. I just came from Rwanda, where they're making very good efforts to eliminate, as I'm sure you know. And just having observed this firsthand and talked about it and thought about it a lot for the last while, as I'm sure you have, those of you who are optimists about eliminating and eradicating, when you look at some of the social conditions and the cooperation that would be required to eliminate, even with the best possible technical tools, you know, across educational strata, social groups, economic groups, populations that are not well educated, don't have germ theory as part of their everyday thinking, really, how do you think that how could this happen?
Great, thank you very much. Someone up in the gallery.
Considering that we've talked a lot about the biological difficulties of creating a vaccine or drugs to deal with malaria, why not and actually looked at how in developed areas like in Nigeria, where the oil companies invest in creating a situation where they can deal with malaria, why not take the money that we would invest in trying to create a vaccine and put that into actually trying to develop the countries economically, and in that way you would think that with development would come the elimination of malaria within those countries.
Lady down here, halfway up.
Hi, my question is directed at Robert. It's about how your idea of working on malaria long term is a very logical idea. But as Eleanor was saying, the political situation doesn't often allow for long-term effects. long-term approaches, and if you take into the account how the money that you would be spending on a long-term approach could be spent on short-term cures, do you really think that the political situation is going to allow you to do that?
Asking Robert to talk about politics, right? Okay. And why don't we take this lady up here, and then we'll stop on this round.
This is for Eleanor. I'm a simple clinician, but the fact that we know that sickle cell trait protects you from malaria, and the fact that we know that pregnancy worsens or makes you more susceptible to malaria, how can we use this, or could we use this to develop something?
Fantastic. So what I'm going to suggest is I'm going to, the ones that were specifically named author questions, so Eleanor and Robert, I'm going to spend to them. Then Tony, you can pick which of the other he wants to do, and then finally Janet gets the dregs, not in terms of the question, but in terms of the answer. All the questions are excellent. Eleanor.
So, sickle cell is just one example of many that we have now of genetic differences in populations that make them more or less susceptible to malaria. And so there are genome sequencing projects and genetic association studies being done that are actually pulling out all kinds of genes where there are natural polymorphisms in the human population that make you more or less susceptible to malaria. Those are useful because they help us understand, if a gene is associated with protection from malaria, a human gene, that means that human gene is involved either in the way the parasite grows in the host or the way the immune response is. So we can use that, and we are using it, and we are using those genetic associations to say, aha, there's a gene, there's a pathway, we had no idea it was involved before, now we know it's involved, maybe we can use that in terms of developing a better vaccine or a better drug. So we are doing that, and that's the basic biology that Tony was talking about, is helping us to learn. I don't think we can use it directly. We don't want to start selecting people based on which genes they have or whatever, but we can definitely use that information. It's a very powerful tool. The issue of pregnancy is interesting, and it may be the one that we could crack with a vaccine, and it's quite complicated, but basically there is a particular subset of the malaria parasites in the body that go and that home to the placenta of a pregnant woman. There is a molecule in the placenta that isn't present in the normal human body, and these parasites go and stick to it. And they use a molecule to stick in the placenta, which seems to be quite conserved, and people are actually targeting that parasite molecule to make a vaccine that would protect pregnant women. And of course, the advantage of pregnancy is that you've got a limited proportion of the entire population that is likely to get pregnant. You could vaccinate, for example, teenage girls, so that with a vaccine that lasts 10 or 15 years, and you could actually prevent quite a lot of malaria in pregnancy. So it's one area where we might be able to make a difference. And there is increasing interest not just for malaria, but on targeting vaccines now to adolescents. There's it used to be said you would never do that because why would you just go out and vaccinate? No, but now we've got things like HPV vaccines. And that the idea of targeting vaccinations at adolescents is a kind of growing area, and a malaria in pregnancy vaccine could be one of those type of vaccines.
Robert.
In trying to answer your question, right, there is at any time a discussion as to the balance of money that is spent on basic research versus application and use of knowledge in the field situation. That is an ongoing discussion. It will change over time as scientific opportunities permit and money permits. So I don't think you can put that in a rigid basket, all right? That's point one. Point two, I think I would make is this, that over the past 40 years, there has been a phenomenal amount of basic, really good basic biological research on the malaria parasite. That has resulted in a very serious reappraisal as to how we should develop reagents, looking at compounds now that will stop the parasite being transmitted as opposed to saving the life of the individual patient. That's come from basic research. So, of course, there we're now beginning to see the payoff, right? And that's why we continue to fund the basic research. The other component, though, that I would add is I'm going to be critical of the whole scientific community now, or provoke the whole scientific community at the moment and say, I think we're brilliant at doing basic research, answering those wonderful questions that we pluck from the air and have these games at producing these lovely scientific ideas. I think what we are less good at as scientists is actually standing back from that data and asking, how can we turn that into something useful? Right? And I think there is an area, this word that's used by the politician, translation of the research. I think the scientists themselves should spend a little bit of time thinking, how could this be used? And if it can't be used within the foreseeable future, to accept it might not be a priority, but it is their fascination and do it with less money. Right? But things that are potentially seen as useful, I think, yes, we should spend more time developing those.
Thank you. Tony.
Perhaps I should just address the question of, I think somebody up here raised that rather than paying for malaria control, we should pay for development in Nigeria, I think was suggested. Well, I would say, I'm not sure that would work, but I think one thing we could do would actually be to help people in areas where malaria is endemic to make their own contribution through the development of good clinicians, good basic scientists, to actually contribute to doing the research that will actually build the infrastructure that will feed into all of these applied approaches, whether it's good epidemiologists to look at the patterns of malaria, or whether it's good entomologists who will understand the mosquito vectors, or whether it's good medicinal chemists who will develop good drugs. So that's the sort of contribution I think we could make, and it would really make a difference in terms of solving these problems. I'm not sure we should pay for development, but we should pay for we could pay for educational improvements such that people can also help themselves and take over from people like Bob and Eleanor and myself. And this is really what we should be trying to achieve. And Janet, of course.
Janet. I get missed out of all of these things.
I thought I was going to get that question, so I was just asking what the final question was, which I think is, rather than go for eradication, should we put money into the economies? Is
Economic
that right?
development. I think that was right from Rwanda, obviously.
Yeah.
Is that, do you want to say your question again, Heidi?
Or how could we do that, given the baseline that we're starting from in somewhere like Rwanda?
Something like this happening.
Yeah.
There's lots more to say.
So I don't think it's going to happen in my lifetime, but I do think there have been huge changes in the last 40 years that I've been working in malaria. So the statistics that everybody would have been throwing around when I first started were over 2 million kids a year dying of malaria. Now we're talking about much smaller numbers than that. So I think there is movement. We have better tools and technologies now. We're getting better at putting them on the ground. I do think the arguments, the economic arguments, need to be made hand in hand with actually rolling out these disease programs so that they're not just in silos, and that the national governments understand the economic benefits of what they're doing, and that we actually measure some of those alongside the simple health benefits that we're putting in. Because unless you do that, I don't think you're going to get the political will to take things forward. But I wouldn't underestimate the difficulty of putting these things in on the ground in the situation that we work in those rural poor populations. You've obviously worked there, and I've spent a lot of time in those populations as well.
Thank you very much. I deliberately decided to put all the time into the questions because I thought they were really excellent questions all the way through. we're almost at the end of our session. I was asked just to sum up a few comments for 5 minutes at the end. I'm not going to try to summarize all the points that people have made, because I think they made them really clearly, and I think that's sort of your intelligent audience listening to intelligent speakers. I think you can make your own summaries. I make just a few additional ones, and I'm going to some extent, address Robert's challenge to me on this one. Because I'm part of, I work most of my time for government, and I have to make choices between one thing and another, because you're given a fixed budget, and a choice to do one thing is a choice not to do another. That is the reality. Let's start off with the biology. You have 4 outstanding biologists, and this is National Biology Week. Malaria, having a very complicated life cycle, is not just beautiful, although I share the views of those who think it's beautiful. I'm a malariologist myself by inclination and training. But it also provides multiple places you can hit the parasite. And we've heard about this at every level. You can do it at the mosquito level. You can do it in the body at very many different areas. You can look at the parasite directly. You can use drugs. You can use vector control. Potentially, you could use vaccines. You can use social interventions of various sorts. So its complexity is, in one sense, its Achilles heel. So in theory, that should make it easier to eliminate. But as Eleanor was saying, its complexity also means it's phenomenally good at adapting. Its ability to get round things we throw at it, both the mosquito and the parasite, is very considerable. And this is a very resilient infection, and you will never find a single tool, probably, which will get rid of this, in my view. We will always have to use combinations, very different from something like smallpox. So the biology is a strength and a weakness if we're serious about controlling, and potentially if we're serious about eliminating. Now, I will now reveal my own prejudice on eradication and elimination. The difficulties of this are not primarily biological. In my view, they are primarily to do with the political difficulties. And the real problem with elimination, and almost every eradication attempt has run into this, I would highlight 3. The first one is that elimination is, there's a geographical paradox, which I talked about earlier on the back of someone's comments from one of the questions. There's a geographical paradox that malaria elimination and eradication is most popular in the places it is least possible. So malaria eradication is very popular in Nigeria, where you cannot do it, and it is very unpopular in Latin America, where you can, because they see that this would be an enormous amount of money, and what would be the huge public health benefit? Not much, because very few people get malaria, and most of them are poor anyway. So there's a geographical paradox, and there's also a temporal paradox. People were very enthusiastic about polio elimination when there was a lot of polio. Now in the northwest frontier of Pakistan and the north of Nigeria, people say, you keep on coming around with polio rounds, and my children are dying of diarrhea, pneumonia, meningitis. Why? They wouldn't have said that 40 years ago, when they were seeing polio cripples everywhere, but they do say it now. So there's a temporal paradox, which makes it very politically difficult. And then the third thing is the thing which has derailed the majority of eradication campaigns, is either we've got the biology wrong, which is what all of us need to think about, or we've got the social science wrong. And I thought that the points that people made earlier are really important. It's the politics, the way society will respond, that is what has tended to stand and put spokes in the wheel of very many of the eradication campaign results. There are people who believe, like Robert, that the best thing to do in the world is to eradicate everything. And basically, if you're going to eradicate it, it's got to be good. And then there are people who believe that you start off with the things which are causing the biggest morbidity and you basically chip away at them. And they are almost opposite approaches in public health terms. They do meet in the middle. And I think you have to make your own choices, because very intelligent people take both positions, and most people are somewhere along that spectrum. So you've had a very good debate here from 4 outstanding biologists and public health people, as they demonstrated when they switched from their malaria hats over to other things. They don't just do malaria, despite what it may say on their biographies, because they were done this. Very many thanks to our speakers. Many thanks to the Royal Institution for hosting us, and for National Biology Week for giving us the possibility to talk about this, and to all of you for extremely good questions. Thanks a lot.